some of the free body diagram for help of different numericals. First is, this is the case, there are two identical spheres, they are equal in size, they are at some angle. So how to make FBD's free body diagram of these two spheres? So let us see. First sphere, one reaction is coming from here R1, one reaction is coming from here, contact point towards the center. Now whatsoever is the angle of the horizontal of the inclination with the horizontal will be the angle of reaction with the vertical line. W is the weight reaction between these two spheres. So R3 will come like this. This is going to be a parallel line to the plane. That's why this angle is going to be 30. Now against this, if we'll see the FBD of this, so we'll have R3 at the same angle, 30 from the horizontal, alternate to this, then R4 at 30 degree from the vertical as it was there in this case, and the weight. So this can be used for further making equation of equilibrium. If a single sphere is like this, so it will have two contact, one here and one here, so there will be two reactions and one weight. If there is a sphere like this, a wire is connecting its center, so there is going to be a reaction from contact point towards the center like this R. There will be tensile force or tension in the string, and weight W is going to act like this. We can use Lami's or summation fx0, summation fy0 to solve any kind of unknown. If there are two spheres in a vessel like this, R2 and R1, then the FBD is one reaction on this will come from here R1, one from here, that is R2. Weight will be acting downward. One reaction R3 will be there from center to center. R3, the reaction opposite of this is going to be on this R3 at the same angle. W1 is the weight and R4 is the reaction at this point. So this is there. And how to determine this angle theta? This is by the geometry of the figure. We can complete this triangle and we can say this angle theta can be determined by D minus R2 minus R1 divided by R1 plus R2. So this is how we can determine cos theta, and then by using question of equilibrium we can solve any of the unknown. Now if there is a case like this, there are two different angles. Here is 60 given for example, and here is 30. So the reaction is going to be this reaction on this surface will make 60 from the vertical. So this is what we have done here, 60 from the vertical, and this reaction will make what was the angle here, the same will be from the vertical of this reaction, and weight is here. So we can use Lami's or summation fx0, summation fy0. Another case of FBD is taken here. There are three spheres instead of two. So what we can do, we can again make try to see the reactions. One is coming from here, one is coming from here, one is here from contact to contact, and one is the weight. So this has been shown here. Again we can determine the value of theta by making a triangle like this, as we have done in the earlier two sphere question. We can determine the value of cos theta as D minus R2, D minus R3 minus R2 upon R2 plus R3. So this is how we can determine cos theta. Similarly we can do for the upper spheres. So reaction is coming like this, RC RD from this contact point, then a reaction is coming from here like this. Opposite to this there is this RE, RF and W. Again alpha can be determined by completing this triangle, and we can determine the value of alpha as D minus R1 minus R2 upon R1 plus R2. So these are three FBDs. We can determine cos alpha and cos theta, and whatsoever is the unknown can be determined. Another question like this is there. So we are having two spheres. Now the contact is here, here, here and here. So what to do? One reaction is coming from here, one reaction is coming from here. Whatsoever was the angle of inclination is going to be the angle of the reaction from the vertical. This angle alpha can be determined again as d minus r1 minus r2 upon r1 plus r2. One reaction is coming from here, one is coming from here, and weight is coming from here. Another FVD can be taken here. Another FVD can be taken here, where we are having there are number of objects associated together, so we can make free body diagram one by one. For this member we will have reaction HAVA because it's a hinge support. Similarly at B, HB and VB. Now reaction of this will go to the other elements which are having common point. So at this, if we'll make FVD of this, so opposite to HA will have HA, opposite to VA will have VA. We'll have, this is again a hinge point, we'll have VC, VC and SC. Again opposite to this we'll have on the next element, that is like this, we'll have HC opposite to this, VC opposite to this, and opposite to this we'll have HB and VB. Now T is going to be tension because a string is passing over this. Now again pulley is connected with this member through a pin joint, so there will be two unknowns, HD and VD, and opposite to this the reaction will be there on the pulley and tension on the string, and this is the block is having tension upward and W downward. So we can make the equation of equilibrium, and we can solve for any unknowns given by using 3 equation of equilibrium or 2 equation of equilibrium. Here we can make 3 equations, here we can make 3 equations, here we can make 3 equations, here we can make 2 equations, here we can make 2 equations. However, we depending on the, like here only one equation can be made. Depending on the unknowns, we can plan the question and we can solve for a complicated kind of numericals. These are some hints which can be useful for solving the problems on free body diagram.